So, welcome to Successfully Using Ansible. This is a Bay Piggies and Meetup presentation for today, the 26th of June. I have 20 examples, 60 minutes, and one module to review. When I last did this, I started talking very fast toward the end, and I still was in an hour and 30 minutes. So, I don't want to talk fast in the beginning because we're trying to get everyone up to speed. We're trying to be very patient for those who just have never even seen an SSH command. So we are going to start off with a little bit of SSH. For those who want to go a little sleep with that, don't worry. By the time we're done, you will have to raise your hand and say, Glenn, shut up, you're too fast. All right? So in some ways, if I see the entire audience doing this, maybe, it's time to tell me to slow down or speed up. Don't know. All right, some quick introductions. There are a couple of groups here. The Bay Area Python Interest Group is the organizer of this particular event, and they have great talks and great speakers, except for maybe this one. The Silicon Valley Python Meetup, they're actually, I said the Bay Area Python the first time, right? I've messed those words up before, and I had to go back and say I'm sorry. So the first is the Bay Piggies group. That's the group that's the organizer. There's also the Silicon Valley Python Meetup group, and that just has a really good audience. So people have the speakers, we have an audience, put them together. All right, and LinkedIn, of course, for the very, very great space, great food, but there might not be food tonight, and absolute great hosts for giving us to us for free. So that's really, really awesome. Really, I was going to change this slide, and I haven't yet to have a little cheese with my wine. So Ansible project at work was delayed for 3 months. The idea was, let me just make this talk. I'll do it once a year. This talk will be way after I do it at my current job, so I'll have plenty of time. And I was delayed another 3 months by a project that just will not die. My laptop crashed this week, so that's pretty bad timing. And I took on a very rewarding personal project, which I really liked. It took a little bit of time. Oh yeah, and I broke my collarbone again. So the last few months have had me really behind in getting the slide together. And so that led me to a complete meltdown at my job, saying, I have a slide in 2 days. I don't know what to do. Please give me time off. And my boss was so cool. Not only did he say, look, just work on what you need to go. They're a Ruby shop. They're not a Python shop. But they're like, just do what you need to do. I understand. This will be great. And when you're done, make sure you put in a slide for our company. So this is the company I work for. It's called RepairPal. If you have a car that's broke down, you want to know what's a fair price, go on, find out a fair price. They also they have shops that have been certified, so you want to find out who's really good. So that's the company I work for. I put in my slide. Thank you very much, Matt, for understanding. Great boss. Wouldn't change it for the world. There's a quote from the people from this particular company. If you're not embarrassed by your first version of your project, you've launched too late. No worries. I haven't launched too late. I'm going to be embarrassed. All right, let's hold on to your hats. Everything is available online. I've tried to get this down earlier, so go get your Ansible tutorial if you don't have it already. My glenn@glennjarvis.com is there. I will give you everything you need afterwards. In addition to this talk, after this talk is over with, I'm going to have special Google Hangouts where we will actually go through code. We will review the code together. So we'll actually do example 1, and we'll have a question and answer session. You will have plenty of time to have feedback for questions for that. Now I just want to give you an overview so we understand what you're looking at, and so you can look at everything that's there. So try to listen instead of really following along. You're going to miss a lot of stuff trying to follow along, especially toward the end when I start cramming a lot of things together. And I can't move that little guy in the corner. I'm sorry. I don't know how to. I can't get rid of him. So, but that's okay. We can still see the slides. So here's our path tonight. Phase 0, we're going to define the problem. Some very good questions are coming up. What's this used for? How is Ansible different? Do I use it to make some kind of testing websites? Do I use it to deploy code? What is it used for? And I think that's a good understanding if we have a lot of new people. We're going to spend some time actually talking about what it's for. For those who already know, give me a little patience. We'll get there. Then we're going to actually connect and understand. We're actually going to see how we're going to just connect to a machine. What is this SSH thing? We're going to take a little bit of time for these 2 phases. Then we're going to start saying, okay, how is Ansible used as a command? How is it different? Or does it look the same as phase 1? That's okay. Let's go on. Phase 3, we're going to actually start understanding an Ansible play. What is that? What's happening with that? And then we're going to break that apart and do something called understanding roles. And then we're going to write our own custom modules. Or really, we're going to review quickly a module that I wrote. So that's what we're in for. And you can tell I spent more time on code than I did slides. This is my wonderful graphic. I'm a graphics artist, can you tell? I have broken this down into what I would call, if you were to look at, like, has everyone heard of a lamp stack? Lamp stack? Yeah. So Linux, well, there's really hardware under that, but then you have the operating system of Linux, then you have an Apache web server, so that's the A, then you have some kind of database, which is the M, and then you have Python, of course. So there's the lamp stack that we're talking about, and you can have all these different layers. They're sometimes on the same machine, but they're just different pieces. Well, here's an example of, including the hardware, a lamp stack. And when we start looking at it, we have the hardware piece. The hardware piece is something we've already talked about. Today, we will not talk about virtual machines other than just spinning one up. There's another talk. I sent it out. It was a talk from last year. How do you build virtual machines? We're going to use Amazon. Doesn't have to. You can use anything you want, but it's very simple to use Amazon for tonight, and that's what I'm going to use. So that's the hardware piece. The top piece, we already have a lot of people deploying code. Fabric is awesome for deploying code, and if there's anybody from the Ruby world, Capistrano as well. But in the Python community, Fabric is used to deploy code all the time using very good technology. So if the top and the bottom is taken care of, what we have to try to do is the stuff in the middle. So if I have a particular machine and I need to, and I've tried to say this a couple of times, and I'm not sure if it's going to come across, so I'm going to take a little bit of time to try to read the audience, not to involve a lot of questions, but I do want to make sure I get this understanding. Why would we use a tool in the middle? If I want to build a database server, let's say that I want to put Nginx on this particular machine. That doesn't come out of the box. Out of the box, that bottom level, what I get from a virtual machine is like a default empty. You put the blank CD, or you CD in and you get a blank install. I have to install the Nginx, or I have to install Apache. That's something that you would do in the middle. Why automate that? Why would I automate that? Well, you know, why automate the virtual machines? The idea is if I can automate all of these pieces, then I can spin up entire architectures, test them, break them down. Lots and lots of things like that. And so the idea is if I can have this automated code of all the pieces in the middle, then I can be able to spin up entire virtual machines. So let's say I'm using Amazon, and I start an Amazon virtual machine. And I have a machine running, and it's been working for a long time, and it was installed and configured through legacy code. This never happens, I know, but it was installed and configured by other people, and it's been around for about 6 to 7 years. It's running the entire product. A couple of people have managed it over the time. We don't know really who or what it does exactly, but there it is, and it works. So who's going to touch it or break it? Your boss says, we just published this really cool article. It's going to triple, no, I think it's going to have 10 times the volume. I need 9 more of those machines. Can you give them up? Oh, and I forgot to tell you, that actually is going to hit live in about an hour. So I want you to, what would we do right now if you have to try to spin up an entire machine that you have, you know, that's already there in an hour? Now you're on Amazon, so what's the, for those who actually know Amazon pretty well, what's the first little thing you might think of? A good trick that might work. Take a snapshot. Yeah, okay, great. I don't need to do all this other stuff. I'm just going to take a snapshot, and I'm going to actually put this snapshot out there, and I'm going to spin up other machines like that. And that actually may work, depending upon other things. Now, if your Nginx configs might have something like a host name that's very specific to them, and that host name is dependent upon the traffic, and you have cookies that do things very specifically by host name, then things may not work. But it may. So at that point, though, what if now your boss says, oh, we have... Have you heard of this Heartbleed thing? Yeah, I heard of it. Yeah, well, it looks like we were vulnerable. I want you to rebuild those entire machines, and I want you to rebuild them in a way so that we know that it's exactly the way it was. It's just rebuilt so there's nothing else that's there, and just move the data over. Just move the actual data over. Oh, and that has to be done in the next hour, too. Now, all of those things are possible when you have an architecture underneath, but not so possible. Like if you can have a code that has all of that scripted, okay, great, I'll spin up a few more machines. But even if I have an Amazon machine image, an AMI, how am I going to be able to spin up that other machine? It's snapshot. I'd have to rebuild that machine from scratch. And if I don't know the history of it, you know, it's not in the code base, how do I know the history of who's worked on it? Another reason to have as a history is if it's in a good code base, then you actually can see what people did and why. So these are all things to use Ansible. It's not for deploying code, although you could. It's really not for spinning up a machine instance, although you could. It's really, I think, in my opinion, for the stuff in the middle. If you wanted to also spin up some machines, you could. It depends on really what your needs are. But I want to focus on where its strength is the stuff in the middle. And I know we have Ansible developers in the crowd, and so I'm waiting for someone to say, no, we would not do that. Okay, good. So we now, I think, have defined the problem. But I want to make sure that, is there at least a general understanding of what, without taking too much time and without completely sniping me off of my track of getting this in an hour? Just nods, yes, no, maybe. Do we understand the purpose of Ansible generally? Enough that I could go on. Okay. All right. Then what we're going to do tonight is actually learn some basics on how Ansible is working. Ansible is really just it's simpler than so many other tools. I think, in my opinion, it's actually the simplest. It has the easiest learning curve, I think, because it's written in a language that I know. It's also a lot of configuration files. It's simple YAML, and there's also some nice cool stats about it was the top 10 and above 5,000, over 5,000 stars, all kinds of good things about that. So I'm going to take a break from the slides, and we're going to actually look at this repo that we've done. You need two things. Well, first you'll need a virtual machine, and from that you'll need two things. Live demos suck. Guess what I'm about to do? A live demo. Yay. Why will this not stop? Okay. So I am about to start a virtual machine. Okay. I'm not going to go over the basics. Just because live demos suck anyhow, I'm going to pick a medium instead of a small. I'm going to leave now, see, here's where I'm going to need some extra pair of eyes. It's much easier by myself, but when I'm suddenly doing it now, I'm rushing through and not looking at things. I need you guys to help me catch mistakes. I'm going to configure just one instance. I think all the rest of the defaults look okay. I'm going to leave the hard drive stuff about the same. I'm going to say, so that's the machine that we're building. Now the security group, I do have an existing security group that I'm going to use, if I can find it. This resolution's terrible. Okay. Oh, I forgot to take a couple of ports away from that security group. That's okay. No big deal. There's actually nothing on it. Even though it says production, there's nothing on it. So we are about to launch. I'm going to choose an existing key. That's the thing that we need. It's called example key. And I know that if I lose that key, I'll never get to the machine. So that's all we're going to talk about for building a virtual machine. That machine is now being built as we go. And here we go. That's the machine that's building. And it looks like it already has an IP address. So I'm going to take that IP address that I'm going to need, and I'm going to take a key. Code will be on one side. And runs. Okay, so if I am here in the tutorial, I'm going to go into source. I've made it easy for you for the first demos for people who don't know. I'm actually just I wrote a configuration program that will worry about permissions and locations. Check to see if you've actually pointed to the key, and if you haven't, complain. Just to make it easy so you can see what's going to go on. Whoops. So what's the path of my Amazon key? Type. So that's my key. So two things you're going to need to connect to any machine. You're going to need a key, so you have permissions, and you're going to need the host name, which I just lost out of my buffer because I copied the key first. So give me a second. Is this the live demo? So I don't actually do another box. Yes, it is. And now, so I've configured this machine. All the rest of the things are going to use this configuration, so it'll be simpler. Okay? So for the very first example that we're going to go through, example 1, code, because help you is we're going to machine, and this is the command that all this is doing is making sure the keys exist and gives you a command. We don't need to do anything. Can everyone see that screen? Okay, it's large enough. So all this is an SSH command. Why make a program? Just to kind of help eliminate errors. All we're learning to do is I have a machine, can I connect to it? So SSH -I, what's the identity of the key so that I know I can get to that machine? That's the secret. The username is EC2 user. For those who are using OpenStack, we have another branch of this which will actually let that be other users. It's not yet merged because live demos suck. Let's not merge some code like that I haven't tested. And then the IP address here. Now I actually was going to put make a DNS for that, which I've done before. I think the IP is fine, especially since I already pasted it in and I want to keep going. So I'm going to press enter, And first time I connect, by the way, you've never connected to that machine. Are you sure that's okay? Yeah, that's fine. Okay, I've connected to this machine for the very first time. It never existed 5 minutes ago. And it says, oh, you need to run sudo update. Don't do that yet, because that's some of our other demos. We do it like 6 times in different ways. All right, so I'm going to just exit out of that machine, and just to prove to you that it's the exact same thing, it's just that command. And exit out. So why talk about SSH? Well, one, you need to connect to your machine, but two, SSH is how we are going to do everything. Ansible is using SSH under the scenes. It's so simple because it's just doing SSHing all over the place. Very, very, very simple. In fact, to auto-update machines. Any wild guess what you think this might do? Yeah, update the machines. Good. Just to kind of make sure everyone's paying attention. Now, how am I pulling out that key and the IP address? I'm just reading those config files that we're going to use in Ansible to grab that. It doesn't matter. It's really all it is in this case is, again, we just have this particular command. So what is this command doing? We are using SSH to run a command on the other side. I'm going to SSH to you. I'm going to run an update over there. I should see the results. Okay? And that's pretty cool. I'm actually seeing that machine update. So all Ansible does under the scenes as we go to 3. Oh, I hate when I do that. Every time I do that, I think it's the same one. Rah. And so, no. Example 3, I don't even have code to run. I just wanted to show you what's going on. Under the scenes, what I was doing, and here's where yell at me and correct me where I'm wrong, but I said, look, I want to figure out what it's doing. I don't know how this is working. So as I'm running Ansible, I'm going to go onto that host machine. Can you still see? That way or the other way? Yes. Okay, good. From here it looks okay. I can't see what it looks like there. Okay. So any bigger? Okay, so basically I ran an Ansible command, and then on the other side I'm like, PS, what am I doing? Oh, let me PS, let me grab something. Oh, look, it's creating this big thing over here. So look, it has this file. It's SCPing a file over, it's copying a file over the other side, and then executing it, just like we were doing a little while ago. So I'm executing this file. How simple is that? I'm going to take a little bits of code, put it over there, execute it. Simple, simple, simple. And what's it doing? Oh, wow, there's some dynamic cool stuff. Arguments, very cool. It's actually taking some arguments and things. Oh, I like that. Maybe we'll talk about that sometime at the very end. But here's an that I grabbed from over there. Quickly, we're just looking at it that when we talk about modules, it's about a Python code that we are just putting onto the other side, executing it, and having things happen. If I were to execute it now, it says I don't have any arguments. Oh, actually, there's no yum on my Mac. Okay, fair enough. That makes sense too. So at the end of the day, this is just a command that we executed just like that. And you can have arguments intercross, lots of debugging tools of how to use Ansible hack, things I probably won't have time to do, but there's a whole advanced new talk on just creating modules. That'll be cool. But just trying to make sure that we slowly bring everyone up to speed, we have virtual machines to review. We connect to those virtual machines through SSH. Ansible just uses SSH, it moves a file over there, executes a file, and it does what it needs to do. Simple, simple, simple. And every time I do another step, I'm just going to SCP. So much simpler than a lot of the other tools. I love it. No mistakes with any of that? That's pretty accurate? Okay, good. That's what I've determined, but I didn't write the code. I was just poking at it, and that's what made sense. All right, enough of that. We're done with SSH. We're never is about. So this README, it says, I am going to run a module as a command. Oh, do you move it over again? Is that better? So I'm going to run the Ansible -m ping command. Web servers. I don't know what web servers are. I'm confused. Ansible -m ping. Okay. M is a module that is going to be ping. A module is that little bit of code. So we're going to go find that ping piece of code. We're going to throw it over on the other machine. We're going to execute the code. We're going to grab the results, and we're going to now go to the next step. Okay, what's web servers? Well, when I did this for you, I actually, oh, that's really terrible. Okay, imagine there's a line return there. I created a file for you, and in my examples I did this really cool demos deck, and I forgot to do it this time, but it doesn't matter. This demo works both ways. So you have a group of all hundreds of thousands of web servers, which actually just has one in it, the one that we're looking at. So if I wanted to run this on 30,000 machines, assuming that that's not a limit, then we would just throw those 30,000 machines here, run that command, and it would run all of these. So enough talk, Glenn. Let's see it work. Okay, so I now have run that command ping, gone to the other side, run that module, and get it back. Did it change anything? Making sure the audience is awake. I'm not talking to myself. Did it change anything?
False.
False, no. Good, and ping responded with pong. Very good. So that's not really that much different yet looking than SSH-T, where I can run commands, except it's doing this file thing, but it doesn't look that cool. There are a couple of other things we can do that, by the way, aren't in the slides. I just suddenly that it needs it. I can do other things. I can go ask for all kinds of other cool information from Ansible that's going to figure out for me too. Like, for example, what processor am I using on that virtual machine? Or if I need to know another variable that we don't know yet, where things are mounted at, I could go find that. Or I could go look at some network devices. Cool, there's some awesome stuff underneath just from running a single command. It is just like a command, just like running a shell script. But if any of you have done what I've done, is you have to build this machine. You have to try to automate it. You don't have a tool. Shell works. Let me make a shell script and let me make that work, and then let me make that work. And you just keep piling it on. But then you spend so much time because every time you change one little thing, it has to build for an hour before you actually find out that you made a typo, a syntax error. The trick of this is these modules are we're going to start taking the idea of code and put them into deployment. Two concepts, idemnipotent, meaning that I can do the same thing 100 times, it shouldn't change anything. It doesn't matter. Once, twice, 50 times, it's the same. If I do it, I can undo it. It's not going to, unlike my scripts, it's not going to break about 30,000 times. The next thing that's going to happen is not only is it going to be idemnipotent, it's going to have some kind of encapsulation where things related to each other are kind of, like my scripts were never, especially when they were trying to build lots of things, were never encapsulated. I would have this hanging off of that one, and I didn't know where that dependency was, and it was just a mess. So these are the things that we're going to get into. So we have another command that can be done through Ansible, not SSH. It doesn't look that different than the SSH, but we can do it as well. So do you expect to see how many people, raise your hand, think that this will actually change files on the file system? Well, be more precise. How many people will think a new package will be installed by this command? It would, and it should, except I already installed the packages 2 minutes ago. So because the other command already installed the packages, it just is a faster demo. It says, look, no packages were marked for update unless one just came out 2 seconds ago. So trick question, but good. You're right. Normally it would have actually showed you the same thing. So just So just because we can't have enough ways to do things, I want to now take a step back and do yet another way to update those package management. So each time we're looking at it now is I'm actually sending these files, I'm thinking of these as commands that I'm running across each time. I need to step back and let Ansible do its work underneath, and I need to start thinking of a higher level. I need to start thinking of this as a checklist of things, where it doesn't hurt to do that checklist over and over again. If you were to go talk to your manager and say, what's on, like if you ever look at someone's old notes of what's on that computer when someone configured it 7 years ago, you're lucky to have such notes, but I don't, But let's imagine that you did. It would be a checklist of it has, MySQL version blah installed. It has this config file. It has these kind of things. So that's the concept of a playbook. I'm not going to flip back to slides. We've just moved now from that next stage to now talking about playbooks. How Ansible, underneath whatever it is, how this thing works together as a playbook. This is a playbook which could have 5,000 steps, a checklist of do this, do this, do this, do this, do this, do this, do this. So we're going to make sure all of the OS patches are applied. I sure haven't done that command yet. Okay, I'm going to run this as a playbook, but it's one particular step. It's also in a particular format that we should talk about. If all I have to do is make checklists, this looks pretty easy. And really, that's almost all the time what I have to do is make little checklists like this. Why? Does anybody recognize this format? Is this a special format? YAML. What is YAML? So markup languages or this, we can look at data in several different ways. Real quick, I threw something in. You will not have this. I didn't check it in yet. But I found myself while doing a dry run trying to say, look, not everyone's going to understand what JSON is. So here's some Python code. It's what kind of data structure? Dictionary. Good. So if I print this Python code out, it's going to print out what type would that show up? That should print a dictionary? Okay. Oh, no, it says some Python. And the format is some Python. So this one right here is going to convert this into JSON. So what do you think the format of that line is going to be? Trick Python question. Just know it's another trick question. String, very good. Because Python doesn't have this idea of JSON. Python has the idea of a text file. Hey, Vicky, can I answer it for you? No, I'm sorry, embarrassed. Type. Okay, so Python, sure enough, it's a string. The first one was a dictionary. The point is, you can look at data in different formats. Internal Python code is going to look different in other kinds of things. JSON can be transferred to Ruby, to Java, to other people. They can read JSON. And so can YAML. So if I'm going to say data types to YAML, oops, except I catted it instead of VI'd it, I guess. 1 second. So here's some string. That format is a YAML format. But honestly, all I'm doing is just going to convert it to Python. Does that make sense? This is kind of a key piece. So instead of talking fast, I'm going to stop for a second and say, does that actually make sense to everyone? Ish? No? Sort of? Okay. Internally, that string needs to be interpreted. Very much like we took JSON and we converted it to Python, this is going to take that string, which really represents a data structure, and convert it to Python. Look, this thing down here, an item, an item, an item, is really a list. When we get done with it, that's really a list. Here's also a list. And in fact, let me just run this so you can see what it looks like. That all we're doing is this string that we talked about really is just another way to represent some type of internal structure. So even though we're configuring things, it's actually just looking at data. So again, simplicity at its best. All right, now, sure, quick.
So quickly, yes. So are you aware of any sort of shell scripts to Ansible Playbook Translator?
Yes. I will show you that at the end. Well, I will at least talk about how you can make your own Ansible role by using a shell, how you can make your own configurable module from using a shell afterwards.
Well, I'm talking about translate. It automatically translates a shell script to Ansible Playbook.
I will show you how we'll use it in our Ansible Playbook. And I will come back to that. Okay. All right, so I forgot what demo I was on. I'm sorry. I haven't done a playbook yet, have I? We just looked at a playbook. This playbook is really just a way of looking at the file. One side we'll look at it, and the other side we'll start executing. Ansible. What am I doing wrong? Playbook examples, thank you. So on this side, I'm just going to run it. Communicating by talking fast isn't helping because it's not communicating. If I can get the information across quickly, great. But if I just talk fast and the information doesn't come across, then it's kind of useless. So please do help me here. So Ansible Playbook, and then the first playbook. And now, while that's working, we are looking at this playbook. And so we are starting this task. And look, there are two things that are happening. One, we're gathering facts. Hey, look, that was that whole thing where we got a whole bunch of stuff. Something else we're doing is how we've done this task. They were already installed, super simple. This is what a playbook looks like. Kind of like, you know, how do things go? You know, this happened, this happened, this happened. All right. Let's start looking at the second playbook. Let's start building on this. Okay, it's time to hold. We're now starting to move on. If that didn't make sense, probably the rest of it won't either. We're going to start stepping it up just a notch and put some parts together. If that did make sense, don't worry. You won't be bored anymore. We're going to start picking it up. I'm going to have to hold questions. My apologies. My fault for running late. At the end, I will answer tons. All right, now I have two steps. The first one is we're going to make sure all the operating system patches are applied. We did that. And the next thing is we're going to install something. Look, both of these are shell scripts. We're running shell scripts, and it's just doing just commands like everything else. And look, it's doing the plays on the other side. So we're running through things, we're installing things, and we're recapping things. But change it yet again. What's the difference between that one and the previous one? They include. Good. So now I don't have two particular scripts. I'm now having an old script. I'm including that script, and now I'm running a new command. So this get is now running, but whatever was in the first one is also running. So what do you think the output would look like over here for 3? Will it be the same or different than what I just? Whoa, the same or different than what I just saw? Oh. Do you think it would have been the same or different than what we just saw? Wild guesses. Same. Yes. Good. Trust me, it is. Okay. So now let's look at Playbook 4 since it's already. What's the difference between this playbook and the previous playbook? It's so tricky. When I did my dry run, I thought, oh my gosh, I copied my code. It's exactly the same. Only to realize later, no, it's different. And I had tried to break a point, and I didn't even realize what my own point was. So I don't know if you guys can see what the difference is. We have a Yum module. Yes, good, excellent. We have a Yum module. It's no longer a shell, so now we're stepping out of the whole let me run a whole bunch of scripts. Now we're like, I have a module idea. Yum is a module that can do things. Look, idempotent. Just make sure it's present, this thing called get. You know, just make sure that get is present. Don't try to do all the other stuff. If it's present, that's great. You can run it a million times as long as it's present when you're done. Good. And did it work? Sure enough. Does it any different than the last one? No. Same thing, just another way. But I'm introducing concepts as we go. We can now include. We now know what modules are. We have a shell module, and we have a Yum module. Good. All right, let's look at the next one, number 5. How is this one different? Whoa. So will this file that we run be any different than the previous one we just ran? It's doing the exact same thing in just different ways. I think we're sick of updating that package manager, don't you think? All right, so I'm installing a package. I can now say, look, I have a package to install, but I'm going to say get. If I want to pick another package, I can. And that name variable comes in here. It looks a lot like Django. It looks a lot like templating. So I can template these with variables and have them do more dynamic things, and they're idempotent. And I can be able to build these things up and kind of keep them the same and different. That's kind of interesting. Cool. So will this be any different than the other ones? No. There are some that you get by default. There's sometimes you will get a complaint that says they're not there, but a lot of times you make a default one when you first build your scripts, so that if you don't define one, you'll get one automatically. For example, there's something new called a debug module, and that debug module has a message that you always provide it. And if you forget to put a message in, its default variable is hello world, of course. So sometimes they're there already. It really depends on how you define them. If you make your own ones up, you probably want to set a default. Good. The order is not going to matter here that I can see, because you're defining your variables and then you're applying. There are two different sections. We have variables and we have tasks, and your tasks are going to have your variables. I'm going to real quickly.
So how can I freely use my shell script?
We'll get to your shell scripts. Hold on. 15 minutes. It's not yet, but 15 minutes. Be patient with me on this one. All right, so that was number 5. Variables. Did variables work? Hey, they did, and I didn't check in. So variables are one thing. We'll actually start saying, look, this playbook has a lot of things in it, like variables and other things. What if I want to break those into different pieces? That's not a bad idea. Sorry, because I have a broken collarbone, I might look funny doing this. My apologies. I'm like, oh! But you can break them into other pieces. So if I'm whinging in pain, it's not because of response to you. It's my own embarrassment for being up here. How's that? So variable can go into a playbook, and task can go into this other thing too, and we'll get into that. So it doesn't really matter, not from what. So we can get there, and so we can get to your shell scripts, because we got to hurry up so I can get to your shell scripts. Let me get to the next one. So let's look at Playbook 5. So what concepts have we learned? Is this 5? 6. So what concepts have we learned so far? We can do scripts. It's just working as SSH underneath. There are different modules. We have lots of different cool modules. We can include modules into one another. We can have variables as we do other things. And something else. I can put variables onto a module when I include it and override something. What package would be installed here? Oh, by the way, just for fun, I'm going to get out of this for a second. I'm going to cat my Ansible host file, and I'm going to get my... Just to prove to you that this wasn't a canned demo, my Julia Child. Whenever something for live demos doesn't work, I always have one in the back burner called the Julia Child, that turkey you bring out of the oven that still was baked ahead of time. Look, that doesn't work. So good. All right, so if I actually run this guy, will I get Nginx installed? It was 6, right? So my playbooks are getting shorter, but my work's not getting shorter. I'm including this guy, but I'm not installing Git anymore. I'm installing Nginx. And if I run that, did I just run that? Okay, so Nginx is installed. And if we really want to prove it to me, go onto that machine. No, I'm not. Oh, that's what's wrong with my host name. My host name doesn't have HTML in it. Let me copy. I copied the host name over. You can see that I copied this entire host name over. To save time, trust me, what I could do, I'll ask you, do you want me to do this just to prove it, the point? Go in there, uninstall that package, run the thing again, and notice that Nginx is available. How many people believe me already? Good. Good. So that's number 6. What things we've learned? We've learned different modules. We've learned a couple of them. We've learned how to install Nginx. We've learned how to use variables. But let's... I don't understand. I haven't started my Nginx yet. That's kind of weird. Has added another task. This is not a handler for those who are like, wait, but there's no handler there. No, I don't know what handlers are. This is another task. So we're going to first install the update. Oh, and I should be having it run while I talk. I'm going to run this thing, I'm going to install the package, each of these things are happening, and then I'm going to have the Nginx start behind the scenes. And if that really worked, then hopefully I can see something. Whoa, cool. Hey, we have a deployment. We always have a deployment, but it looks cool. We have something visual to show. Yeah, all right, cool. It's kind of a boring deployment, but we have a deployment. All right. So what if I wanted to start that Nginx service though, but I didn't want to? What I want to like I could re-import that task each time, but it may not run what I wanted to. I want to be able to not have that. Oh, by the way, what else did we learn? There's another module called service. Service started for Nginx. And there is a bug coming up, so if there's a confusion, don't forget there's a bug here that has been fixed, but not in this repo because I don't want to change my repo. Not while I'm doing this. I have a stopped bug that actually is stopped. It's the wrong state. Even though it's supposed to start, it's actually stopped. But here we go. We are starting Nginx right afterwards. If I wanted that to happen when something else happens, I want it to happen as soon as I installed Nginx. I want it to happen like triggering it. I could do that. Cool. I have a handler. If I want to have a handler is nothing but a task, really. But it's a, I keep looking at you because I'm waiting for me to say something wrong. Forgive me for doing that. And at some point you're going to come back and say, well, it's not quite the same. But from my understanding, it's exactly like a task. It acts like a task. It looks like a task, except it doesn't run in the sequence as everything else. So we have vars, we have tasks, and we have handlers. If I execute this, even though we don't have a way of showing it, would this start Nginx? I guess I could do this. Do this. Start Nginx. Before it gets there, quickly answers yes, no, full? No? Why? Okay, fair enough. Good. Pretending that it wasn't started, would it start Nginx? Actually, it wouldn't. It's a good question. It's a trick question on purpose. Don't feel bad. I like it when we do this because I'm trying to engage you by asking tricky questions. Why? Because it wasn't part of our tasks. It's something I got confused with when I was first learning. I'm like, I don't understand. It's in my list. Why isn't it running? It's not running because it's not told to run. All the things that are told to run are to install the upgrades and to install this desired package name, which is up here called Nginx. So it installs it. Sure enough, gathers facts, installs it, but doesn't actually start it. So how do I, if handlers are nothing but tasks, but they don't run, what use are they? So let's go ahead and get those tasks to work, and let's see how they work. They work because they're notified from other tasks. So I have a task that does absolutely nothing. That's okay. The point of this task was just to show you the trigger. So I'm going to do something that echoes an output that you're not even going to see. Okay, but after that's done and it returns a return code of hey, that was good, a happy return code, it's going to say, oh, now when you're done, I want you to notify these other tasks, or handlers actually, that they need to be able to run. So after this is done, oh, I should be having this run while I'm talking to save time. So after this is done, we should start seeing, we should actually start Nginx, and we should even stop Nginx, maybe not in that order. We should start a fizz and we should start a buzz. Notice that the order is probably a little weird. Fizz, buzz, stop, start, It's going to be in the order of definition, not in the order of listing. Okay? But after this task is done, true idemnipotence is that once this is done, all of these things will happen. All right? All of these things will happen. Okay, we want to get to shell scripts, so I got to hurry faster. One more thing. I just really mentioned it. Notice the debug. You have a debug as well. So if you want to try to figure out what variables are set to, you're kind of stuck, you can just debug as you go. Now this debug is kind of boring. It just says fizz. All right? All right. I think we're out. No, oh, we're out. Here is another very, very short playbook. Okay, it's not so short. This is called, I did not write this playbook, by the way. Was written by Fred Alger, I don't know him, but what it does is it shows you all the different things. Lots of explanation. We have the host part, lots and lots of things, but probably the most important parts is vars. So you have vars, you have tasks, you have handlers, and a few other things. What if I could take these, and read this later, we're not going to run anything on this, and what if I could take this and say, look, this is great, I can include other things, but I'm going to get very, very messy by including other things. I want a concept where I can take these guys and break the vars up into that piece. And I want to take these other things like templates and break them up and put them over here. Oh, we haven't said templates. Tasks and put them over here. And we want to take these other things and we want to put them over here. We can do that. That is really just a very roles. Good. So this thing does a whole bunch of stuff. This particular role, these playbooks we have, my first one is going to install Python. It's going to actually upload some Python. It's going to import a virtual env. It's going to put a bash profile into place and do all kinds of things. How big do you think that playbook is going to be? Huge or tiny? Wild guesses. Sounds like it would be huge, but it's not. Because we're not now thinking of the same thing we were thinking of before. We have these other playbooks that we've now broken down into pieces, and we're calling them roles. And so we have like playbooks of playbooks, in a sense. So what I'm going to do is look at, so that particular thing just says, I'm going to make this think like this is a Python stack, or this is Nginx, or this is something else. So if I now need to put playbook together, and my boss says, you need to get that up and running, and it has to be done in like 2 days. Oh, no, I'm sorry, 2 hours. Oh, no, wait, it's going live now. You need to actually have a Nginx installed. I would say, okay, I can do that, not a problem. It needs to have something else. It needs to have another role of Django. Okay, that, not a problem. And then I can run this against the servers, and it will just work because my really what part it's the roles. So let's just go look. I've been running this. So let's run the play. The first one. It's a little doing a lot of stuff, so I want to let that run. So if I start looking at them, I have 1, 2, 3, 4 roles set up. Really 3 roles set up in common, which is kind of an organization tool for me. And so I have these 3 roles that we will have on our servers when we're done. That'll be cool. So if I want to look at the Python stack and there, look, we break it into pieces. We have vars, and these are directories. We have vars, we have tasks, and we have handlers. But we also have something else, files. So if I want to take files from locally and put them up there, I can do that. And I have templates. Very much like tasks, handlers are just special tasks. Templates are just special files. So let's go look to see if I have any files here. I do. I have the virtual inf. I actually push the entire thing up there and then extract it and do some fun stuff. In fact, we actually see it right here. Well, not there. That was an intentional thing that was intentionally ignored on purpose. It's done already. So I have virtual inf already installed. I don't know that that's true. I will show you later, but we log in, go to that box, you'll actually see that I have a Python virtual inf set up there. I'm going to go ahead and start the second playbook while we still review the first playbook. These get a little longer. So if these and each one of them are run, each one of these modules, or each one of these files, very much like in code, have main. So if there's a main in there, it will try to run it. If there's a main vars, it will try to have those as main vars. If we have main templates, it'll have main templates. If we have main task, it'll have main tasks. So we know everything except for one that's up there. Let's look at the tasks. And you're right, sure enough, this is huge. You're right, there is a lot of stuff here. It is huge on this one because these are the tasks that that particular role is doing. And so what are we doing? I'm adding a non-privileged user account, which I will later call in my vars. It happens to be web user. So I've just installed a web user account. So I now can install a very isolated, no one else has access. It's not going to run as root. This is all going to run as a different user that no one, if it gets compromised, only that user gets compromised. Okay. Also, it gives me the chance to show you different things like uploading a virtual inf. You could just do a pip install, but it's more about teaching than it is about running in production on this one. I also did this create SSH directory because we need one. So we now have an SSH directory up there. And then something I've never seen before, but we'll actually look at later, is we actually have a grant. We're going to grant that particular row special permissions. And then we upload the package. All of these are in variables. We extract the file. So this is really just a shell command, a cd to that directory. Look, more variables. Extract the file. And then start executing. And now clean up after myself and run those.
So, a very quick question, since you mentioned this. I actually would like to a high-level question. Ansible is written for distributed system?
We'll hold off on that one, please. Just 1 second. We'll get to shells first, and then I'll get to that one.
But the shell is for non-distributed system. How do you use them?
We have 15 minutes. I'm going to have to say sorry. All right, so we have the second play. Let's see something cooler than that. I now have run the second playbook, and I'm running out of time to show you what it does, but I happen to, it's a 500 error cool. Really, is a 500 error cool? 500 error, well, that's kind of cool. So this is a 500 error. That's a 500 error page. It really is a 500 error, and we're getting closer to having Django installed, so I just roll the thing up. And plus, oh look, my web server can show me a cute kitten. Okay, it's not that cool. So the idea is all of this stuff can be configured. This role put Nginx up there, and it configured Nginx, and we're going to go look at that one while I run the very, very final of all of the examples. We're almost done. We'll get to that soon. Okay. So we looked at it briefly. But I'm going to now look at a web server stack. Now the web server installs inside of a particular user that is a privileged user. So the Python stuff needs to be there first, at least that user needs to. So if I look at those tasks, oh yeah, we have one more thing in this big set of things called meta. I know what vars are. They're variables I can change and substitute. Don't forget, all of these examples you'll be going through yourself. So we're trying to give you a very, very quick, and yes, I know it is quick, through what you can do. We're going to go through this on your own at any time if anyone's interested, and actually do each of these examples, scratch your head, and say, why did that work? You should already have the code in front of you. But conceptually, we have files, things are uploaded. I have templates. Well, let me look at the templates inside of my Nginx. I want to be able to say, oh, look, I have an Nginx conf. So if I want to configure Nginx to be differently, look, my boss has Nginx run as a different user on machine 2. I change this one variable name, and every place else that uses it, including this Nginx, is actually going to change that variable configuration to use it. These are a lot faster. At that point, I want to show you one last thing. Too fast toward the end. Speed-wise, too fast? We will definitely do that. I'm lost.
For advanced users, if they have experience.
Quickly, I think I'm losing us just a little bit. So I'll try not to talk as fast, and I'll try to engage in questions, because talking and yammering on. It's about how much information that we can communicate. Good. All right, so now what I want to do is address, because I use an IP. Let's my desktop. Thank you. I don't know why car doesn't work. It's not what I meant. I want to say. Onto that machine and look around. I went way fast in the last part. So I said I was a web user. Oh, okay, maybe I believe it. User account has a sample project inside of it. Oh, look, there's some public. What is in there? Oh, cool. Hello, world. That's my Nginx stuff. Hey, look, that worked. By the way, this is a machine that we never touched before. This was all completely deployed, and so I could do it on 100,000 machines, and you now have a Django run server. The most exciting Django app I've ever made. Okay. We are technically out of time, and I haven't gotten to the module yet, but I think that's okay. I can tell that maybe if you were to judge yourself as an audience, we were saying I walked in not knowing anything about Ansible, and I really just wanted to learn the very basics.
Yeah.
Okay. I probably should have gone a little slower than all of these things. The next thing is, oh, I already knew Ansible all as much, and I wanted to actually, I already knew Ansible very much, and I want to do what was very, very cool and awesome, and I want to see what kind of advanced stuff, like how to write my own modules. Okay, 4, 5, 6 of you. I'm going to give you a 5-minute breakdown of modules. I wrote my own module in this particular case. It was a module I don't even know if I needed. I wanted to show it off, and I didn't know how to do something another way, so I just did it. Thank you. My machine. Okay, get out. And now I'm in the roles. I have something called a library. I wrote a custom module that was one of these steps that we were executing. And that custom module, what it did was, I have an account called web user. I only have one key. My EC2 user has those permissions for that key. Web user doesn't have those permissions. I could do a lot of SSH keygens, but there's some funniness going on. You know what? I'm going to cheat. I'm going to copy the permissions that EC2 user has and give them to web user. But when I'm done, I want to put them back. And that's what this library does. This library several of them. It says grant access, deny access. Several times we saw grant access, deny access. And make a liar out of me. Oh, here we go. Temporarily grant access. So I can write my own module and have it execute like everything else. There are things that we didn't see, like conditional execution and things like that, but that'll be for later. So what does a module have to do? From my understanding, what I've learned is that a module is going to be a bit of code. I don't care. It could be in Bash. You can have a bit of Bash. You can have a Bash function. Yeah, you can write absolute Bash. It can be anything you want as long as the code can execute it. The first argument sent to that thing is going to be a file name of where your arguments are going to be. So your Bash script is going to basically say, great, I'm going to do all these things in Bash. And now, first thing I have to do, though, is I have to say, oh, wait, you're giving me arguments. I have got to figure them out. Parse them like you would Unix shells.
The problem of lots of Bash script is written for single machine. That's the problem. So I ask question, how to migrate the single machine shell script to Ansible or anything?
Afterwards, I will answer you. Okay, but what I'm saying is we need to split your particular. First thing you do is you have a parser, and that parser is going to say, here's your command arguments, here's your different equal signs, those are the arguments. So you got a lot of extra overwork. Then after that, you actually run your script, and the output you print to standard out JSON text. You can do that in Bash. You could do it in Ruby. You could do it in Java. You could do anything else. You could do it in Python, and guess what? If you do it in Python, you get some library, and it doesn't actually get written to a file. So they'll parse the arguments for you. So what does this thing do? Give me an action. I'm going to either enable or disable the security access. Okay. Here are the keys that we're going to have, secondary keys, and all I do is take those actions and run with them. The rest of it's just Python code. Okay. The documentation is here. James, thank you very much for keeping me on task. I'm apparently way out of time. Questions?
Yeah, so my question is, virtually I can...
Besides Bash questions.
Yeah. As you know, Ansible is written in Python. But, as a programmer, we can use any language to accomplish what Ansible accomplishes.
Absolutely.
But, the question for you is, we have lots of existing shell scripts which is working for single machine or a little number of machines. And we would like to migrate those existing shell scripts to be reused for the distributed system.
What I would do is I would take that shell script. I would put that shell script into an Ansible role. That Ansible role has 5 pieces. One of them is files. It also has templates. From now, I'm going to assume that you're going to have to customize that Bash script at some point. Every machine might have to have a slight difference, like a host name on that machine. So I'm going to put that in templates. And then I'm going to tell Ansible, one task, whatever machine I'm working on right now, take that shell script and put it on that other new machine. Then I'm going to tell Ansible, execute that machine, because shell is one of the commands. And then, because I don't trust other people, I'm going to say, now clean that up and remove that other script because I don't want it to be there anymore.
There's no translator right now in the market. You have to do it by ourselves.
Yeah, and Ansible will do all of that for you. And it's one. I will actually write one for you and send it as part of this demo. I will write one for a shell script and actually show you how to do that. No arguments, though. But I will have you have a shell script, send it to the other machine, give a results, and execute.
That's either, one machine works, for example, I remove a file on this machine, and if I have 1,000 nodes, that's enough for all nodes.
I won't do 1,000, but let's do 10 nodes.
Yeah, I mean,
we would do that. We would take your Bash script. In fact, 10 nodes, we can do 10 nodes.
I think the question was also like
how to reuse
them to Ansible, not just translate them.
There's no tool that's going to take that code and make it into Python. There's no Bash to Python converter, but you can have small...
For Ansible Playbook. Shell script running by single machine to be applied to a huge distributed system.
You can do that. If you want to convert your shell script itself, can that shell script be broken down into pieces? For example, is that shell script going to install a package? Convert that to an Ansible 2 lines, make that a package installer. What else does the shell script do?
A lot of things.
Well, okay, each of those things are going to be a different task.
There are so many legacy shell scripts to be translated to Ansible Playbooks.
So what I would do is not use the legacy stuff. I would take that script, I would put it on a system, I would actually deploy it and run it on that system and customize it, and then over time build new ones, and the legacy will eventually go away. Yeah?
Run in parallel or
yes. Should be parallel, but I've never run more than 5 or 6. Each machine is series?
Well, I think you can define a number that it runs for, right? So if you want that all under the time.
I thought that was in parallel. You're saying it's not in parallel.
It's not a rocket science, to be honest. Ansible,
it's not. It's very simple. But that's elegance. To be able to do something elegantly and simple is awesome.
C++, right? I mean, you know.
Yeah.
Can roles depend on each other?
Yes, they can.
Can you repeat questions?
Oh, I'm sorry. I will repeat questions. The current question on the table is, can roles depend upon each other? And yes, they can. Let me show you a role that depends upon another role real quickly. To show you, if I can get into my roles again, I'm going to show you that this web server actually depends upon the Python stack because I use it somewhere. That make sense? You asked the question, who asked for the, does that make sense? So yes, that means that as soon as this role tries to execute, it's going to say, have I run that one yet? If not, I'm going to go run that one. If I have already, I'm not, well, depending, I might not have to bother. But if I have several at the same time, it's fine enough to only do it once. Good question. Error handling is a very good question. I got to the very end where I started going bleh and missed some of that. Let me show you an error handling that I did toward the last. It was web stack main tasks. Okay, that was silly. Hey, look, there's one. So completely skipped over a lot of the details because there are a lot of details here. But here's one where I actually cheated. I wanted to know if the virtual env was installed or not. I'll just ls a directory that exists there. There's another way called creates for other things, but I was doing something dumb and cheaty just to show an example. So this is going to ls a file that doesn't exist. So the very first error handling is, do I care? I'm going to ignore those errors. But I'm also going to register a variable. So that output is saved into a variable, and it reports in JSON errors or not. So you can actually see the errors there or not, besides completed, changed, errors, things like that. I'm going to save that variable is virtual env installed. And then I'm going to say, look, I can conditionally run a particular task when that variable shows me failed, meaning that it's not installed, then execute this one. The first time this ran, it went so quickly, the first time it ran, it said error in red, and I made a little point of going, oh, that was on purpose? That's what that was. But then the next time, it just said skipped, because the win wasn't sure. Your error handling is you get JSON back. Errors can be in that JSON. So any script can interface. Yeah?
Let's say your distro may vary, right? You might have well, the package name is...
I expected to see a package where it was just package state installed. It's not. It's individual. I don't know why. Instead of having yum, I guess it's just to be leaner. But like for example, I would want the text to say, am I on Red Hat or am I getting the variable of CentOS or whatever it is, then use the yum part. If I'm on Debian, use apt-get part. I don't know why it's not like that in that module. I've never read that one.
So,
yeah?
So do you think you know, anyone can pick up Ansible in a couple of hours? If you have smart, you know, probably a couple of minutes. But anyway,
you just did.
My question for you is, you know, you just like me as an engineer, this is a very good talk. The problem is too detailed on it.
Excuse me.
Getting my question. My question is, do you think Ansible gonna take over both copy and shift?
No, not yet. Too early to tell. Yes, a question.
If I want to install a specific version.
If I want to install a version of a package, yes. I believe that's probably, let's, Google is my friend. I'm going to say Ansible docs, which by the way are pretty good. Ansible docs yum for those packages specifically. Here's the yum module, and is there a version? Oh, it's built into the name. In the yum package, at least it is. Does that make sense? I didn't know, but apparently you can do it that way. I don't know if it's going to be the same through all of them. Yeah?
So this is kind of like an interpreter pretty much. So you have a syntax which you put in your YAML files and takes that and interprets whatever, so you can have your extend the language with your own.
Oh, or is it a DSL? Is it its own domain-specific language? It's really just data.
Right. But the question for you is, like, we keep on repeating this event potent capabilities, but we didn't see how potent is the event potent stuff. Like, for example, break something in the middle and try to...
Break something in the middle? I love it. Okay. I tried, see, you have to realize because live demos suck, I tried so hard not to let anything break in the middle, but now I have permission to make it let it break in the middle.
It's easy, right? Because you just repeat the operation and
yeah.
I'm asking for cases where you don't have event potent, like for example, you may have timestamps or other things.
Let's break some stuff. I like it.
No, I don't think it's you do what I'm saying.
I'm sorry.
Right. So I'm saying for cases which are event potent, you just repeat the operation and everything is fine. I'm asking for cases that are not event potent, like where you have timestamps in a you try to make every role or every task be that. So if you have those, handle those in a way that it is idempotent. And that's why you didn't see these failures. I was about to go break a lot of things, and I was going to cross my fingers that it fixed everything, that you would see the whole thing run again. But I was going to go log in and delete users or change users or keep an ID. If something breaks, it will actually tell you, oh, it broke here, and you'll have to fix that. But generally, it just repeats the task over and over and over again. And how do you roll back? Like, you have to write your own code to roll back things, or roll back?
When you say roll back,
like for example, you added the web server.
How do you remove a role?
No, roll back, meaning like you added the user to the ETC code, and you want to remove that.
I'll give you the answer that I know, which may not be right. I added a role, and if I want to remove it, I would actually have a task called remove role.
I'm not talking about role. Roll back means like you change back transaction. Transaction is changed, right?
Yeah, there is no such thing. What I'm saying is that I know of. No, wait, is there? Yeah, no. What I'm saying is what I have done is created that user, and then I made another one say delete it. For example, that's what I did. In my particular module, I had several cases that could go wrong. I take contents of a file and I dump it to a backup file. What if someone tries to execute on that backup file? It's not timestamps, but if someone tried to basically run that task again, we was dumping contents twice, and I had a security leak. So I had to make sure that if that backup file exists, skip it. So things like, for example, you have a particular backup file that is not supposed to exist. You want to back up and try to overwrite that file. Skip. I said not allowed. It would just be idempotent that it wouldn't try to enable something that was already enabled. It would just say skip because it was already enabled. Now, disable would say move it back. I'm going to try to disable something that doesn't have a backup file. Skip. I can't disable it. So by keeping your logic very tight that way, you can...
If you have to write compensating transactions by yourself, I think for large cases can become very complicated.
Yes. I don't have the magic wand for that. I wish I did. Because then it would be great to just roll it back, but I have no idea how to do that. Yeah. Oh! That's a great question. If I want to say I'm running on this particular machine, what is its IP address, for example? Your inventory file that I have one single entry for can be dynamic. So you can actually have, as long as it finishes and returns in JSON, whatever magic it does to try to figure all that out, as long as it reports in JSON, it doesn't have to be a file. It's just an executable. I've already. In fact, I have like 20 examples that I played with that I could go dig up and show you that would actually do that. I don't know. I love it. Very cool. Any other questions? We're out of time, but people have been asking great questions. Oh, yes. Oh, sticker for Ansible's on the back. Cool. Cool. A couple of things real quick. I want to just say is that if you ever want to know something and don't know it, you say, I really want to know it better, volunteer to have a tech talk and have no idea what you're talking about. And then melt down to your boss that you need 2 more days. Okay, so with that said, we're going to end the talk. We'll have questions afterwards. Not a question, not a problem at all. This has been great. I think maybe as I look at my very first one, am I embarrassed by my first example? A little bit. But ironically, I'm always up here thinking, oh gosh, I'm not going to know what I'm talking about. There are going to be things. I better make sure I can get all the advanced people. I actually think it was a little too advanced. I think I pitched it a little too early, and I maybe should have gone a little bit slower in the beginning. But in general, I feel happy. I got up here and I learned something I know a lot more than I did a couple months ago. All right, the talk is over. So now we